So let's discuss parallel lines, just a little bit of a refresher off of what we covered earlier this year. Now here we see a large collection of parallel lines. Every colored line is parallel. The colored lines are parallel, so I've got that marked there. I should turn on my writing implement. So all my colored lines are parallel. Now, when you have parallel lines, you have angles that are congruent. Remember, the angle pairs that we call congruent are things like alternate interior angles, alternate exterior angles, corresponding angles. Maybe that's a double R. However you spell it, doesn't matter. What are my other congruent angle pairs? I guess if we have any vertical angles in there, they'd also be congruent. So let's look at some examples here. Angle 1 is, I shouldn't put angle 1 there because it's not an alternate exterior angle, and I want to put examples that match. Let's find some vertical angles first. So vertical angles is when two lines cross. We get some vertical angles. So angle 1 and angle 4, those are vertical, and they're congruent. If I picked angles for alternate interior, I'll go with angle 8 and angle 9. Those are congruent. For alternate exterior angles, well, what if I picked angle 13 and angle 20? Or if I pick some corresponding angles, well, angle 9 corresponds to angle 13. That'll work. Now, you'll also notice that I picked all the obtuse angles when I was doing this exercise. I guess I have skipped over 16 and 17 and 12. But all those obtuse angles marked in red are also congruent to each other. So angle 1 is congruent to angle 20, angle 4 is congruent to angle 9. All of those obtuse angles are congruent to each other. Oops. Let's pretend like this said obtuse. And this one's saying acute. I apologize for doing those out of order. Let's go ahead and list our acute angles that are congruent. What are our acute angles that are congruent? Well, they're what's left. 2, 3, 6, I guess I skipped 5, 7, 10, 11, 15, 14, 18, 19. All the acute angles, all acute angles visible are congruent. Now, our final thing we should probably talk about is list the congruent right angles. Well, are there congruent right angles? No, there are obtuse angles and there are acute angles. So there are no congruent right angles. Although any right angle would be congruent to another right angle. Okay, the last thing it asks us to do is list all the supplementary angle sums. Now remember, supplementary angle sums is when we take an angle, we add another angle to it, and we get 180. Now, in order to do this, we just need to pick any acute angle and obtuse angle. Now, I noticed that angle 19 and 20, for example, form a linear pair. Now, linear pair, that adds up to 180, so that's obvious that 19 plus 20 is equal to 180. It might also be obvious that, say, angle 18 and angle 16, because they are consecutive interior angles, that angle 16 plus angle 18 was equal to 180. But it might be less obvious that any other combination of an obtuse angle and an acute angle in this situation will produce 180 degrees. So if I picked, say, angle 15, which is acute, and angle 9, which is obtuse, that'll add up to 180 degrees, as will any other combination of an obtuse and acute angle. Okay, let's talk about triangle similarity. There are acceptable reasons for triangles to be proven similar. Remember, the takeaways from when things are proven similar is we have congruent angles, and we have proportionally related sides. Proportionally related, so that's when you can set the fractions equal to each other. So let's go over reasons we can prove triangles similar. First reason, angle-angle similarity. This is the easiest reason. If you can pick any two angles that are congruent, then technically we know that the third angle is also congruent because all triangles add up to 180 on the inside, right? Interior angle sum is always 180 degrees. So if you know two angles are the same, you know that the third angle is the same. So angle-angle similarity is the simplest way to prove two triangles are similar. Now, if you know all the sides of both triangles and you can set up a similarity statement where we have those proportions, then we can prove them similar. So you either need to know all the angles, which is over here, this is knowing all your angles, or all the sides, over here, knowing all the sides, or a combination. Now, the combination has to be very specific. You'll have to notice that we know angle A, right here, and angle X are congruent. And that angle is in between the two sides that we've marked proportional. So as long as you have your angle side angle side, where your side is in between your, where your angle is in between your sides, side, angle in between the sides, you can prove the triangle's similar. The fourth and final way to prove triangles similar is using hypotenuse leg. Hypotenuse leg is a special case, of course, because we need to have a right triangle. Now, if we can prove sides are proportional, in this case we have side AB and DE and AC and DF, so we have hypotenuses and legs, then we can say that they are similar. Now, one thing that's kind of cool about this is notice that that right angle isn't between your two sides. So this isn't a side angle side scenario. This is a hypotenuse leg scenario. We don't necessarily know that angle A is congruent to angle D. And once we've proven that similar, we do, but initially we do not. All right, let's work through a couple of proofs. So we're going to choose the option that best fills in the blank for filling out the following proof. We are given that we have a proportional relationship. Okay, so let's go ahead and mark up that proportional relationship. I know that EF, right here, that corresponds to HI, and that they have a proportional relationship when you consider the two sides FG and IJ. Ooh, and I also know that this is a right angle. Hold the phone. What did I do wrong? Oh, sorry. I apologize. FE and HI correspond. HI's over here. and FG corresponds to IJ. I totally marked that second triangle wrong. I apologize. Okay, now I can solve. Now, I don't know that my hypotenuses are similar, so I can't use hypotenuse leg, but I have two sides that are marked proportional, and I do know that I have a right angle here and a right angle here, so I might be able to use side angle side. Notice how I haven't actually used congruent tick marks, something like that. Now, the reason I haven't used congruent tick marks is I don't know that those sides are congruent. I just know that those sides will correspond to each other in a proportion. So let's see. So this proof starts off by restating my statements. It says that they're right angles. Okay, I and F are right angles. That's given in my picture. And then it says all right angles are congruent. Okay, so we just pointed out some right angles, and we pointed out that all right angles are congruent. Can we say that angle F is congruent to angle I because they're both right angles? Well, you know, I think that is exactly what we are going to say. That's how we would finish that proof. We're also given that the sides correspond. That's from our given statement. And just like we had hypothesized, the side, an angle, and then a side. So our side, an angle, and then a side. The angle is in between. So that's what's allowing us to use the side angle side similarity statement. All right, let's keep going. We're going to choose the option that best fits in the blank. We're trying to prove that IJ, oops, sorry, that's what we're given. We're given that IJ is parallel to LK. Okay, so far so good. Now we're going to try and prove something by alternate interior angles theorem. Let's see. Now, alternate interior angles theorem helps us to prove lines are parallel, and also helps us to prove that angles are congruent. So I'm wondering, can I prove these two angles congruent by alternate interior angles theorem if these lines are parallel? And indeed we can. Let's see if I and K are the angles we actually care about. Oh, hey, I and K are options. Sweet. Done with that. You'll also notice here that we've proven these two angles congruent, and then by vertical angles theorem, we prove these two angles are congruent. And we don't actually have any sides marked congruent. We're using angle-angle similarity here. Let's do one final proof. Choose the option that best fills in the blanks in the following proof. IJ and KL are parallel. Okay, we already know that. That's drawn here. Nice. Just want to make it bigger. So we say that they're parallel. And then we say, hey, we're trying to prove I and K are congruent. How can we prove I and K are congruent? Well, we're going to use that same trick we did on the last problem, where we just extend our parallel lines to make a statement more obvious. And I extend my transversal. So I notice these, again, are alternate interior angles. Oh, hey, there's alternate interior angles theorem right there. And right here, that says alternate exterior, so I know that's not my guy. And they're not vertical angles. They're not consecutive angles. So I know that this is my answer. And then it says J and L are congruent also by alternate interior angles theorem. So I've got two angles marked congruent. So I should also have angle-angle similarity. There's that problem. All right, so this is triangle similarity proofs. Remember, there are 4 ways to prove triangles are congruent. That is proving that you have right angles, so you have a hypotenuse and a leg that are proportional. Proving that you have all the angles the same for angle-angle similarity. Proving all the sides are proportional for side-side-side similarity. Or proving that 2 sides are proportional and the angle in between them is congruent for side-angle-side similarity.